Hello and welcome. You're listening to Let's Drone Out. We are live. We are somehow still alive, and we are edited because of Stephen. Thank you, Stephen.
Thank you, audience. It wouldn't be worth editing if there were people watching it. So, and thank you to our extra special guest this week, Chris Rosser. Thanks for joining us, Chris.
Nice to meet you all.
And the Lord and Master Andrew/Frank.
Hello.
Who has been sailing this ship for a very long time and is tired enough.
So we spend a long time on this show kind of discussing trends and the history of FPV and flying. But I think amongst recent developments in FPV, and I say recent, meaning the last 5 years, I think Chris has had an outsized impact as the designer of frames that don't just look pretty or have cool names, but are actually designed by an engineer who cares how they fly, which I think is fantastic and long overdue. Hooray for Chris. So yeah, welcome to the show, Chris, and thanks for your work.
Thanks, Stephen. Yeah, I don't know about named cool. I think I don't do so good on the naming front, but the frames fly good, so that's something.
But you can't tell what it's named when it's flying, so you can't tell if it's wobbling to pieces or not. So
yeah, exactly right.
Yeah, but I think previous to that, we had a kind of a slew of frames that basically tried to do what the Apex did, but better. And they tried to do it by changing things more or less at random. And some people, like Kebab FPV, freely admit to just trying stuff and seeing what happens. Whereas I think you seem to have driven like finite element analysis and structural analysis of frames and choice of materials due to their engineering properties and things like that into the hobby much more than anyone else. Where did you start, and what were you flying when you got into this and thought, oh, this won't do?
Oh, what was I flying when I started? Oh, so I got into hobby flying like super cheap, just like from AliExpress, like ready to fly drones that would like fall to pieces immediately. Often before you even take off, and then need like massive rebuild and like retrofit to get them flying. My first like proper drone frame that I started to standardize on was actually the Gep RC Mark V, which I think you can still buy. No, it was the Mark IV. It was the Mark IV that I started on, which so I flew that for a while, and that was when I started to notice like vibration issues with some of the drones. Really noticeable with the 7-inch arm version of that frame.
Right.
The Mark IV
FRC for the 5-inch especially were quite lauded. It was meant to be quite a good frame at the time, wasn't it?
Yeah. For the 5-inch it was okay, but then they did a 7-inch like arm for it, and that was just a disaster.
Oh, right. Yeah. Because the trend back then was if you want a 7-inch, just stick longer arms on it. Obviously, it's just the arms that count, so you're sorted, right?
Yeah, just stick longer arms on, and like don't make them thicker or anything, because that would be bonkers
and get heavier
and cost more.
Yeah, yes, crucially, and cost more, and might require some further engineering of the rest of the frame. God forbid that. I mean, come on.
Absolutely. So this was like a Gep RC Mark IV 7-inch with 5mm thick arms, and it did not fly at all well. So that kind of got me into the vibration thing, and I did a few things trying to like fix that frame, trying to make it better. Didn't really get anywhere with just my random experimentation. And then my background is I'm actually an analytical engineer, simulation engineer by training. So I was like, well, I should just make a model of this and do a finite element analysis and.
You say just make a model of this into a finite element analysis. This apparently was something that you said as a throwaway comment, but people hadn't really done so far, even though
not in FPV, no. But that was the sort of thing that I was doing, like for my day job for other types of products, looking at vibration and resonance in enclosures, motors, fans, that sort of thing. So it was, for me, it was only just doing what I had always sort of been doing for work for the last few years before, at least. So that was kind of how I got into it. starting to do these simulations and realizing, what the problems were, why what I was trying wasn't fixing them, and then starting to think about, well, these frames need to be better designed. And so, being completely naive, I emailed a bunch of manufacturers saying, your frames don't have good vibration. If you made these changes, they'd be much better. And so, surprisingly, no one replied. Shock horror! I didn't get any responses. And so I made a couple of YouTube videos about, doing these finite element analyses of the frames and showing the mode shapes and everything. And I got one of those comments, those constructive comments that you sometimes get on YouTube videos.
You suck.
Yeah. It's like, well, if you think you know what you're doing, why don't you design a frame? And I was like, well, challenge accepted, I guess. So that was when I started to design the AOS 5 V1 back in, 2020 or something. So long time ago. And
perfect for getting out flying during COVID.
Yeah, it was. Flying during COVID was tough. I flew quite a lot of tiny whoops during COVID around the flat. But yeah, so that was the V1 frame, and that had really good vibration and resonance performance. But there was that kind of just started me down the road of trying to do this for more frames and different frames and bigger frames, and trying to improve the simulations and testing other people's frames. I did that for a while, kind of trying to understand the vibration of performance of that. And probably a couple of years ago now, I kind of really got all of the simulations and models dialed in, so that now I can pretty much predict the vibration performance of a frame design just by simulating it. I get within about 1% to 2% typically.
It's got to be your point where you can almost just look at a frame and be like, oh yes, we know what's going to go wrong with that. Or do you still get tripped up, or there's still surprises thrown your way?
So often you can just look at a frame and go, yeah, this is clearly going to be a problem because of something that the designer has sort of not done or done wrong or whatever. So yeah, it's, for a lot of frame designs, it's pretty easy to see what the problem is going to be. The nice thing about doing the simulations is that it's relatively quick and easy to simulate the vibration performance of a new frame design if you've got a CAD model of it. And so it's been really nice for quite a while now. I've just not really been tripped up when it comes to actually prototype testing of frames. So the frames, when I fly them, I fly them and I take the black box log, and I can sort of just match the resonance peaks in the log up against the simulation, and they're, as I say, within 1% or 2%, and you just go, yep, that behaves exactly as it should do. But obviously, it took a year or two to get there, and mainly it's all about how you model the carbon fiber, because it's a bit of a
composite material to start.
Yeah, it's just complicated. It's anisotropic, so you have to get that material model right, and then make sure that in the simulation you have all of the fiber alignment as it's going to be in the final piece, and then it works. But that just takes a bit of time to get there.
And you have to be dead confident that when they make the frame, it's going to come out the same as you spec'd it, right? Which isn't always the case. Notably, there've been some weird cutting in the past, not with your frames necessarily, but we've all seen some frames and wondered, why did they cut it like that?
Yeah, so there can always be weird things with cutting. That I think has become less of a problem over time. I think as more and more drone companies have become much more confident with like how you cut a frame. Like before, I would have to be really specific about, no, you have to have like cut the arm along this orientation, otherwise it will not work. But now everyone's kind of figured out that there's only one way you cut an arm. So when you send someone an arm, they know which way to cut it just by the look of it. But
how long do you reckon that's taken? I mean, where would you say that the peaks and the troughs have been in the industry? It feels like we're all kind of like elder nerds in FPV at this point, but it hasn't always been that way, right?
No, I mean, like peaks and troughs. I mean, I think that we've been really spoilt with like digital systems and how good the image quality is that you can get from a digital system. Occasionally, I go back and I fly, analog systems for testing or whatever, and yeah, you kind of get spoilt by the ease of use of like Walks Now and DJI. So I would say that's been like the transformative technology that I always think of when I'm thinking of like what's materially changed in FPV over the last, what is it, 6 or 7 years.
Yeah, it stands out. We were just saying on the pre-show how excited Chris is every time DJI releases a new product, which inevitably means a new camera form factor,
Oh,
if not
absolutely,
a new BTS form factor that no one else used before.
That's it. Yeah, it's like, DJI love to innovate. And the thing they love to innovate most on is how to mount a freaking camera in a drone. So yeah, that is every time it's always a
the 20mm camera for 19mm frames, of course.
Yeah, that was it. So everyone was using 19mm. 19mm was the standard, and DJI released a 20mm camera that would not fit in any 90mm like hard mounting, which is what everyone used. Everyone was hard mounting their cameras because that worked best for analog to hard mount it. Because you got jello if you soft mounted an analog camera typically. Then after everyone kind of had managed with the 20mm, they then went obviously to 03 with a different mounting, the double screw and much lens array much further forward. And then, this is the great thing about 03. They knew, but neglected to tell anyone that it absolutely must be soft mounted.
Mm-hmm. Mm-hmm.
Like they knew this. Like the engineering team knew this, but when they released the camera, they were like, "No, you just mount it in the same way that you mount the V1 camera, which was a hard mount, and it doesn't work." So that was fun to realize that you can't hard mount that camera because
what does that? What comes down to the hard mounting with that camera then? Because it's kind of the opposite to what you were talking about with rolling shutter and jello on traditional FPV cameras. Why does it need a hard mount?
Well, so the older cameras did fine with a hard mount, and I think it was because of just the way they were constructed inside. Basically, you rigidly mount it. The like sensor was rigidly mounted inside the body, which was rigidly mounted to the drone, which the vibrations from the motors are at a high enough frequency that it wasn't going to cause jello in the footage. And I think what changed with 03 was that the actual sensor board wasn't as rigidly fixed in the camera. And that meant that like the sensor board could vibrate within the like camera body. And if you hard mounted the camera into the frame, you would basically transmit the vibrations from the motors really effectively into the camera, and then the sensor board would wobble around inside the camera, and then it would look horrible. You get jello.
So is it OIS or EIS? I thought it was like technically supposed to be a kind of fixed lens array and fixed sensor, but maybe it's just not as fixed as it needs.
I don't know if there was. It's a good question whether it was like the electrical image stabilization that was doing it, but you would get the jello even with EIS off. So, but then you would get it. It would not always be on every camera. Some cameras were really badly affected. Like some individual units were really badly affected, and others were less so. Which made me think it was like a mechanical thing somehow. And definitely the camera board inside the 03 camera is not mounted in quite as rigid a way as like what we would typically see in like an FPV camera. So like an analog FPV camera. So I don't know. But anyway, that caused all sorts of fun because then I had to, and lots of other people had to redesign their camera mounts to include like TPU soft mounting to make the 03 work. And then 04 obviously is totally different again. So we keep going. But yeah, 05 I'm sure will be different.
So going forward, are you just going to make the front end just modular? Just, DJI are going to try and trip us up, completely modular front end, fit whatever camera you want.
Yeah, so that's what I've kind of tried to do with the V5 frames. they will fit an 04, an 03, a DJI V1, a 19mm analog camera, everything from Cadex and walk snail, HD0. So I've gone pretty far with the kind of universality of that camera cage.
But then you've got to account for what DJI are going to do next time. And can you say with any degree of certainty they won't just be like, why is it necessarily have to be rectangular?
No, I guarantee you the next camera will be wider than 20mm.
Yeah,
I think. Because I think they'll try and cram a bigger sensor in it, and they cannot cram a bigger sensor into a 20mm wide form factor. Like on 04, they've pushed it as far as they possibly can.
Right.
So yeah, I think they might go back to like the standard mini size cameras, which were like 22, weren't they?
Yeah, that was the next size up, 22.
Yeah. So they may do a 22.
It's pretty quick.
Or the parabolic sensor.
Yeah. Wrap it.
I think
so. Yeah,
I think they'll do something. Came out that people were pleasantly surprised it was square because they were expecting some kind of oblate spheroid. VTX. At least the VTX mounting is sane, I suppose.
Yeah, actually, the 04 VTX mounting is a lot more sane than the 03. But I mean, I always just taped my 03 in. I never screwed it in. I just got double-sided VHB and just slapped it on the frame, and it never came loose. So,
one of the benefits of having frames that are predominantly cut out from plate carbon fiber, I assume, is that you have, I imagine, toolpath setup costs, but you don't have tooling costs in the same way that you might have for like some kind of other mass production technique of injection molding or something like that. You're not having to get whole tooling blocks made up.
Well, that's it. I mean, the thing about FPV and why it's kind of an interesting market to serve is that it's like there's not huge volume on any of the sort of FPV frames. So you've not got the volume that makes it worthwhile doing like a lot of tooling, like custom tooling. So and carbon fiber plate is relatively inexpensive and really high performance for like what we want to do. It's very light, it's very stiff and strong. It's very hard to do better than it. I see more and more Chinese companies coming out, particularly on the smaller frames with like machined aluminium plate, which is an interesting choice. Kind of, it's heavier, it's going to bend, but I guess not snap. So maybe that's kind of. I see people playing around with different materials on the smaller sizes. Once you get up to like your 5-inch or 7-inch size, it's all carbon fiber plate, and I think it makes sense.
There was a bit of a trend in the X class, the giant drone racing, to have some aluminium tubes and things like that, just because when you get to frames that are 800, 900 mil across, you start feeling the pinch of the cost of the carbon fiber extrusions. Particularly at the time, I don't know if it's got any cheaper for that sort of stuff with the sort of wider drone market. Maybe sort of expanding that, but definitely at the time, aluminium tube was a big thing. Have you ever been tempted to look at some of the sort of that kind of size of giant drone racing frame?
Yeah, so lots of people have asked me for a 13-inch frame. It's on the list of things I have to design at some point. So I don't know about. I guess I'm moving up towards that kind of X class size, but no one's asked me for like a Beast class or an X class style frame yet.
You have an ultralight 10, right? That's the largest one.
Yeah, the UL10 and the UL10 Cine are the largest frames I've done. I mean, I've always been focused on the like hobby to like just getting into the kind of professional end of the market. And the whole point of the UL10 and the UL10 Cine was like you can grab something like a Sony CVE10 Mark II, which will shoot 4K RAW, and slap that on a 10-inch drone and have something that will embarrass a lot of cinelifters for a fraction of the cost. And that was sort of the whole point of the platform.
Semi-pro.
Yeah, semi-pro, or like, can you get something that's like professional quality, but not professional price.
Yeah.
Like it's
You don't need an Altera. You're not lifting 30 kilo payloads, that type of stuff.
no, and you're not even getting up to sort of the cost of like an X8 Sicario where you're you've got 8 big motors and like more expensive ESCs, and you're running like 12S and all of this stuff that adds so much cost. With the UL10, you can put one together for certainly under $1,000, $1,000 US, or like £750, and then you pay similar amount for the camera, and then you've got something that shoots gorgeous footage, and it's way better than like any GoPro. So that's kind of that was why those kind of exist. But as you start getting up to the bigger sizes, like the 13 and 15 inch, I mean, it's kind of a different price point, and it's moving away from like what, like just your
Different
average
market.
pilot might aspire to. Like, I think we could, like any FPV pilot who loves flying like 5-inch drones could if they wanted to, and they wanted to get really amazing footage, like aspire to like a UL10 with a ZVE 10 Mark II.
It's the same technology set, isn't it? Like, you can start racing minis and micros with Betaflight. You can take that, Betaflight, AM32. You can build a 5-inch. You can build a 7-inch. You could probably take that up to a 10-inch. But you start going to like 14-inch and bigger. You want to learn ArduPilot. You want to think about connecting your ESCs via CAN bus or something ludicrous, and it's just a whole other way of building and maintaining. So
and also like on the price point side of things, I mean, if you want to pick up like an ESC that will do a 10-inch drone, like you can pick up a whole stack for like 120, 130 quid that will do like a 8S 10-inch. If you wanted to do like 13-inch or something, it's going to go up to like 300 quid just for the ESC.
It's a lot, yeah.
One of the reasons I asked about the X-Class is because when I have seen the X-Class frame, quads flying around, they have had some quite interesting noises to them. And I've always wondered, like, is that frame resonance? Is that just sort of because tuning that sort of size quad is a challenge? Is that aerodynamics? Like, they have a very interesting whistle to them. It's a bit like the whistle on the Mustang or something like that. Of like,
they burn out a lot, don't they? Due to resonance, they burn motors from resonance. It seems like a very expensive hobby. There's a reason there's not much of it going on, I think.
I can imagine that resonance on those bigger drones gets to be a big issue, especially if you're coming up from like a sort of an FPV racing standpoint, like a 5-inch FPV, and you're going up, and then maybe you race 7-inch FPV, and then you go, I'm going to build a beast class. Like, none of that prepares you skill set wise for the challenges you're going to face with vibration, resonance, and filtering on a like 13-inch. It's like you can get up to like 7, 8, 10-inch if you've got a really well designed frame, and you don't need to worry too much. And once you get past 10, it starts getting really, really difficult for like a powerful quad that you want to be responsive. I mean, once you get up to sort of 13, 14, 15, 24-inch type props, like really big stuff, again, you're mostly talking ArduPilot, and they do not fly like an FPV. Like they're not as responsive or anything. You don't fly them like an FPV. They're all autonomous. And that's a very different ball game. You're talking about having like filters at like 20 hertz. Whereas in FPV, you'd have a filter at, the lowest filter might be like 75.
So at 20 hertz, that's going to mean your quad is considerably less responsive.
Yeah, it's like flying from treacle. Like it doesn't move. It doesn't like there's noticeable lag on your sticks at that point, and it's not enjoyable to fly.
But these are separate paths, really, aren't they? You've got one path with the racers, and you could argue a lot of Chris's frames are freestyle, not racing. And when you get up to X class and Beast class, those are racing quads. Whereas what Chris is really providing freestyle quads, which when they get bigger become closer to cine quads. not racing quads, and there's a vast gulf between cine and racing. You know, the racing stuff, they're trying to push them as they get larger, but I've seen a lot of the people, just to back off from the power and avoid burning stuff, they don't go full throttle on those rigs. And a lot of the cine people, they're absolutely the other way. They're obsessed with tuning, and they want the thing to fly like it's, you know, sliding over glass.
Yeah, that's exactly it. And so that's certainly more the, yeah, I mean, as I said, it's something that I could definitely look at, like beast class type stuff. But for the bigger, like the UL10 and those, they are all cine or long range frames. Just because that's what, you know, if you know, why are you building a 10-inch? You're building a 10-inch either because you want to carry a camera that is much better than a GoPro and is therefore bigger and heavier than a GoPro, and you need more prop and motor to carry it, or you want something that's super efficient and can fly for an hour, in which case it's very hard to imagine freestyling those big quads. Because I don't know about you guys, but after about 5 minutes of freestyle, I'm knackered and I want to land and have a rest. It's very intense. But if you're flying long range, if you're cruising long range, you can cruise long range for half an hour. It doesn't, you know, you don't get tired out. So yeah, it's just about the actual effort of flying it, I think.
I guess the other reason for your frames leaning towards the cine side is probably because of your specialization in the vibration side of things, and that's where that's going to add that extra value.
Yeah, I mean, like it helps with the cine side of things, because everyone just wants the smoothest possible footage, and so low vibration is the way to get that. And in racing, I think, yeah, I mean, for 5-inch racing frames, I mean, they're so small, they're so compact now that they don't typically have, and they like vibration isn't a huge issue. Like if there's a little bit of vibration in the footage, like it's not really going to be noticeable or matter. Particularly like if you're using like an HD0 type system where the resolution's lower and stuff, like you can't even see it. So I think it's just a different, as you say, different application. They care about different things. I have designed a racing frame. Quite a few people fly it and like it a lot. But it's definitely the sort of the vibration is not typically what racing pilots are thinking of when they choose a frame.
I heard when you released your first frame, Chris, it flew really well, and I remember being able to push the kind of on Betaflight, the master PID slider, put it up to like 200% PIDs, and just thought, wow, this just goes exactly where it's instantly where I put the stick. You know, it was just perfect tracking. I do fly quite gently, but you know, cruising around like a nana a lot of the time, so I didn't break stuff, but people were breaking stuff. And I did notice that as you started revising, you started to include some kind of ease of life type features into frames rather than just being absolute flight performance. How did that evolve, and did that kind of lead itself into racing in any way?
Yeah, so it's sort of, it's the quality of life, and what I've always struggled with, and I think this, you know, we'll all kind of have this feeling, is that when people are choosing a frame to buy, they want like the best flying, lightest thing. And then about 3 seconds after it breaks in a crash, you want the most durable thing. So that you try and find the balance where you don't want to make something that's so big and heavy that people are going to look at and go, well, why is this frame 160 grams? And I don't want to fly a 160 gram 5-inch frame. But you still want it to be durable enough. So finding that balance has been kind of where the frames have evolved over time. And they've gotten a lot more durable without getting all that much heavier. I mean, like I think I've only like added like less than 10 grams onto the AOS 5, like going from V1 all the way up to V5, and the V5 is a heck of a lot more durable than the V1. So that's kind of the trade-off. And then just trying to, as you say, quality of life things, like just trying to make them really, really easy to build. It's one of the things that people comment on, and one of the things I'm really proud of is like I don't ship instructions with my frames, and most people don't need instructions to build them. We have started doing build guides, but those build guides are for people who are like new to FPV, and this is like the first frame that they're ever building. They never built a frame before. If you've built like a few FPV frames before, you get an AOS frame and you're like, I mean, it's just obvious how this goes together. And there are no different parts. Like all the arms are the same. So it doesn't matter what order you put them in, like everything's symmetric. And you can't get it upside down or the wrong way around. So that's sort of what I've been really focusing on. And I think with like the V5 frames, I'm really, really pleased with like, they do just go together exactly as you expect.
Was that something you learned or that you had already from your previous roles?
Oh, I actually, I kind of got, I guess, interested in ease of like assembly of frames. I was actually doing some work for a company called Jewel Labs. So they make vapes.
Okay.
Oh yeah.
And they had a designer there, James, who is now worth lots and lots and lots of money, many billions of dollars, who was obsessed with symmetry. He was like, it must be symmetric, because if it's symmetric, you can't get it wrong. And so I was like, that's actually a really good point. So that's when I started trying to make all the parts of my frames as symmetric as possible, so that, you know, all the arms, for example, are the same. So you can't get the arm, you can't choose the wrong arm because they're all the same. If you need a spare, then it's just one spare, they're all the same. So that's kind of where I've been trying to push to and trying to make the things really, really easy to put together. Yeah, that's just, I don't know how much it matters, but it is something that I try and do with the designs as far as I can.
Yeah. And I guess not having lots of screws and bolts that are almost the same size, making them into distinct sizes as well.
Well, I had a great experience with that because Mr. Steele got hold of one of my frames, the AOS 5 V1 in a video. Mm-hmm. Someone handed it to him and he was like, this is a really interesting frame, but it's got way too many screws. And it looks like it'd be really difficult to put together because it's got so many screws. What's really interesting is that that frame has 4 less screws than the Impulse RC Apex. But apparently 4 less screws than Mr. Steele's frame is still way too many screws. So that was when I decided that we were going to try and go for fewer screws in future designs.
Something about it made it more evident visually, I guess. They just...
Yeah. And what's important, guys, is that I'm not bitter about that, and it doesn't keep me up at night.
No such thing as bad press, right?
Actually, it was great. I mean, actually, loads of people were like, "Oh, it's a really interesting frame. I'm definitely going to try it out." I'm not sure why Mr. Steele was hating on it, but no publicity is bad publicity, and I take all the feedback seriously and try and make the design better.
Because the fastenings, I imagine, is another kind of difficult thing of an FPV frame. Like it's a very key part of, it's going to be a very key part of the vibrations in a FPV frame. And like carbon fiber, as you said, is already a tricky material. But how much effort have you had to put into actually sort of modeling those connections between different carbon components?
Oh yeah, so that is a tricky problem. In general, the gaps sort of, if the frame is like assembled tight, so there aren't any gaps and any wobbles, then in general, the joints either don't do much or they add a bit of damping. But yeah, when I model the frames, so I typically do most of my resonance modeling with assuming that the joints like are stiff and that there's no slip. I have done some models with slip. And as I said, it doesn't change the frequencies much at all, but it will add a bit of damping sometimes. And if it's loose, of course, then it makes everything a lot worse. We can get a lot of movement.
Top tip, heard it here first, tighten up your screws.
Yeah. Oh, that's it. And it's important to make sure that you have a design which is going to apply sufficient like clamping force on the arm to stop it moving. A lot of people will do that thing with frames where you like do that, right? And you try and move the arm. I don't find that like that's not a particularly useful test because if you can move it by hand, you can apply so much force to do that. It's not going to move in flight. Like if there's enough friction in there that it's still in flight, then you don't see any vibration characteristic. And a lot of effort has been put in. I think 533, like they've done a lot to try and like completely remove any movement of the arm.
What's your test then?
Sorry?
If you pick up a frame and you want to see if it's tight or not, if you don't move the arms like that, what do you do?
What I do is I would hang it off a string and tap it with something and then listen to it.
Ooh.
Oh, interesting.
Very
cool. You can tell immediately if it's a good frame by the tap test. Yeah, so hang it off a bit of string or fishing line or like a battery strap or like something that moves, and then give it a tap. You'll know if it's a good frame, because if it's a good frame, the tone will be high, and if it's a bad frame, the tone will be low. You've got to make sure that it's got motors mounted to it. That's the only thing.
Yeah.
But you can do it. If you take a frame, you can screw motors onto it and nothing else and give it a tap and you'll know. And in fact, there's a guy, Vladimir in the Czech Republic, who has done a load of laser vibrometer testing of AOS frames recently. So I have a video on that. And yeah, he did all that testing just with motors mounted and nothing else.
I'm just imagining the shelf that you can't see in Jack's room at the moment of all his quads hanging, just becoming some kind of big xylophone.
Yeah. But yeah, so that thing of seeing if the arms will move is kind of a meaningless test, unless it's so loose that you think that the arms are actually going to move in the air. In that case, it's a problem and you need to tighten the screw.
I did have one frame that did that. It was touted as a folding frame, but they didn't realize that in flight it would tend to fold itself. It was kind of a disaster. The number of drops I lost because they were trying to close onto the quad. Not good. So when we talk about damping, that you hit the press with an amusing trend a couple of years ago. Very well intentioned, I'm sure.
Yeah.
But one that people had trouble getting on board with, which was to add damping grease onto things. And I understand the principles behind it. You're trying to soak up those vibrations. You're trying to, turn them into heat, stop them causing problems. What's the story on damping grease now? Do you still do that to your frames? Has it evolved any? Have you found any slightly easier to use products? Because they were very sticky.
Yeah, I mean, yeah, so that's the thing about the damping grease, right? Is that it does work and it does help. But on balance, I don't think that it's the right approach for managing vibration because it's not user-friendly. So I think that overall, so like I've done some testing like with older frames, like the V2, I think I did the damping grease test with. Like it does make things better. Like it does improve the vibration performance.
I tried it, but it was just all over me and my bench afterwards.
Yeah, but it's just a nightmare, right? Like it's just so messy. It just goes everywhere. So that's a problem. And if you take like a V5 frame and you compare it to a V2 frame with grease, the V5 frame performs better vibrationally without grease than the V2 performs with grease. And so I don't grease the frames anymore because it's just not user friendly. And the way to go about managing vibration is to just keep incrementing the design of the frame to make the vibration performance better and better. And I mean, it would be even better if you added grease, but like just.
Is there something that's easier to work with than grease, like a sheet material? I think like PTFE tape or something.
Materials. I tried some sheet materials. No, they don't work as well.
What about those really annoying, greasy but sticky pads made from the thermal conduction stuff?
Oh yeah, like I haven't tested like
die cut of that.
Yeah, the
like PTFE tape, like you seal radiator valves with. I've got loads of that kicking around. That would be
that's hard.
It's very very thin. You see,
the challenge that you're going to have with anything solid is that solid things don't do as good a job at dissipating vibrational energy as viscous things. So the moment you move to a solid, even if you go for like a rubber, like a soft silicon rubber or something like that, like it's like orders of magnitude worse than the like mechanical damping greases.
So it's back to
they are
Sticky Jack's
really
Fluid
good at dissipating energy. They are really good. Like if you think about like a solid, like you make a solid ball of silicon rubber and you throw it at the ground, it will bounce. If you take a ball of damping grease and you throw it at the ground, it will bounce. Right? I mean, that's the difference.
One
in
has
energy
absorbed the energy, the other one has not.
Yeah, exactly. You know which one's absorbed the energy, right? It's the one that's just gone and done nothing. You know, so it doesn't even like it's not even going to splash or anything. Like it will literally just absorb all of the energy in one shot. So yeah, you can't do a lot better than like a Nia gel damping grease, but I think even though it works, I just don't think it's good.
Maybe the usability will be solved with some brainwave in the future. Who knows?
Yeah. I mean, there are other benefits to like the damping grease. Like it actually makes really good thread lock for screws as well.
Like corrosion protection.
You know the thing about Loctite, which is like it's like it keeps the screws in, but it can make them difficult to undo. So damping grease keeps the screws in, but makes the screws easier to undo. Like it will stop the screw coming out. It will stop it backing out under any situation, but it will never bind up. So you'll always, you know, the screw will never bind in the.
So if you're going into like a steel or aluminium post, or it won't just bind in there.
It'll never bind in there. No, the grease will effectively lubricate the screw when you're trying to take it out, but it will never vibrate loose or back out by itself. So it's like the ultimate Loctite. It's like the best Loctite in the world. But I still wouldn't advise it because it's just so gross. It just gets everywhere.
There wasn't really an easy way to deliver it. You just had like a blob of it, and you've got to get that onto all the parts of this frame, and inevitably it just kind of made contact.
Yeah, it just gets everywhere.
It needs a redneck solution, and that solution is.
Has he got a damping grease syringe or a
sponge on a stick? You need a sponge on a stick. You can buy them. That's what they look like. They come in big packets. They're great for using I use them to remove flux because they don't leave any lint.
That was also the other thing I did end up with then after having to wipe it up, lint all over the frame, and it seemed to attract dust as well.
Sponge on a stick.
Yeah, sponge on a stick. That's what we need.
Do you want me to send you some sponges on a stick, Chris? It's the future.
Specially branded from Sticky Jack's New Emporium.
Are we ready for the future? I'm not sure we're ready.
Future is now.
Fun per volt FPV.
So the other thing that I've noticed
is that when applied with pinpoint accuracy, there is no problem with mechanical damping grease. So that's
when applied,
it's the application that's the challenge.
If you're a damping grease sniper, it's fine, but not many of us are, and you only have to go wrong once, and then it just starts spreading.
Yeah, it just starts spreading. Yeah. It seems like even a tiny amount will cover like every surface. Oh, and if you use the Nia gel stuff, it's really chemical resistant, which is obviously good if you're trying to, you want to dampen grease for like your airline wheel. But it means that you cannot wash it off. You cannot wash it off. It is impervious to soap, water,
ethanol,
isopropanol, like everything.
Dry cleaning fluid.
Sorry, dry cleaning fluid. I haven't tried
This sounds like another good challenge. Next time I'm around Jack's, I'm gonna get hold of some Nia gel and just leave it on his desk, and I'm sure he'll be there trying all the various solvents around his desk.
Yeah. Well, let me know which one works, because I've still got like stuff with grease on it from like when I was doing work with grease years ago. And if you can find out, Jack, what dissolves Niagel, and will it also dissolve my face?
There we go. Here's the Sticky Jacks Glue Emporium new
Challenge.
line of products. It's very, very cheap Niagel, very, very expensive Niagel remover.
Yeah, that's it. Yeah, it's a lost leader on the Niagel.
Can you send me some dampening grease and I will test it? I work with Plastisol and it's ink that never dries. The only way to dry it is by either grilling it with heat or waiting till you die. And then it will.
That's like this stuff. Like you can just you can do anything with it. You can heat it to like huge temperatures and it doesn't do anything. So it's very they've designed it. They've designed it to be like really, really resilient. But yeah, it's not great.
So what cost?
Well, according to the internet, apparently Niagel can be dissolved with hydrocarbon solvents. So
lots
so
of
like
formaldehyde.
Hydrazine.
Formaldehyde or hydrazine. Oh god, I'm not really good. Formaldehyde.
Like a great day.
Xylene, limonene.
Go test this out.
Stuff.
What are you doing? You're either building rocket fuel or you're trying to clean Niagel off your desk. One of the two.
So Jack, have you
and all of those things sound like either they're going to asphyxiate me or melt my face. So maybe my tools would stay greasy.
Fine.
No, you have to be approved for the use of what is it? Like controlled chemicals or something
I think
get hold of most of that.
Hand on the rudder. Moving away. We previously had the Dutch drone gods on here, and I noticed that one of your quads was one of these experimental rocket ship designs. How's that been going, and kind of what got you into that?
I got into that because I met Luke and Mike. In fact, I interviewed Luke and Mike on my YouTube channel. Shameless plug for the channel. And they had just set a world record 480 kilometers an hour when I interviewed them.
Right.
And we chatted a lot about like the technical challenges of going really fast. And foolishly, I made them the offer. I said, "Oh, guys, I'll help you with record attempt. I bet we can do something and go, make the drone go even faster." And they were like, "Sounds good." And so I've been like messaging them back and forth since then, basically, and trying to help them as best I can with like some of the more technical aspects of going really fast.
Like re-entry.
I designed them a motor.
Oh yeah.
I actually have a video about this coming out on Tuesday. The AOS Supernova 3220 motor, the 10-inch sin lifter motor that I designed is, it is a 10-inch sin lifter motor, but it's actually a world record drone motor, world speed record motor.
What prop do they put on that for the world speed record?
It's 8x15, I think.
Oh,
that's 7x15.
For 3220 or 3210, you say?
3220, yeah. 3220, like 800 kV on 12F.
That's a
and
can motor.
Yeah, and in June they broke the world record. They've gone 580 kilometers an hour.
Wow.
With the Supernova 3220.
How does that even work? How do you avoid like supersonic props? Surely the props are just getting crazy speeds.
So the prop tips are like over 0.9 Mach, so they're starting to get deep into compression loss territory.
Yeah.
But the solution is some really good batteries. I think they were using possibly some packs from SMC. I have to check with them. And the 3220 motor I designed, which, I designed it for a 10-inch sin lifter, and I was like, this should be, this might be what you want for a world record attempt. It's about the right size, and it's got the most torque that I could possibly cram into the form factor, and it's made by RC Empower with their super high temperature insulation, so it probably won't smoke itself, even if you push it really hard. And I mean, yeah, they were just taking it to the absolute limit. I mean, this is a motor that's designed. The 800 kV version is kind of designed for 8S or like 6 to 8S, and they're running it at 12S. It's got a maximum. That motor's got like a maximum instantaneous power rating of something like 2 kilowatts, and they're running like 4 kilowatts through it for multiple seconds, like 10 seconds during the run. They had to like cool it with dry ice.
I should think they did.
Minus 80. Because it was getting so hot during the record attempts that all the magnets would lose all of their magnetism. That's an amazing failure mode that I have not seen in a motor before. So when the magnets get really, really hot, they start to lose their magnetism. And the biggest effect that has is it causes the kV of the motor to rise.
Huh. So the motor goes faster.
So
all the magnets.
Current.
Oh, right, yeah.
And so it gets hotter, and so the kV goes up more, and so it draws more current, so it gets hotter, and so the thing just runs away and basically just vaporizes itself. It's amazing.
That's what do you do? More mass. How heavy is that motor? That must be a 50-gram motor or something.
Oh, the 3220 weighs like 150 grams.
Wow, that's a lot.
Wow,
to get that hot, that's so much power.
It's for like a big 10-inch sin lifter, and they're running like a 7-inch bi-blade on it.
Wow,
in moving air that's cooling.
Yeah, I mean,
so you have to like add fins to the outside bell.
Well, that was the interesting thing is that it was kind of just about hanging together when they were testing it in South Africa when the ambient temperature was like 15 degrees. And then they were like, we're going to Dubai. And so they were then doing their like world record attempt runs at like 50 degrees or like 40 degrees, 50 degrees.
That is,
and it was just overheating really badly. But I mean, that's the nature of it. But they solved the problem. They got the record. More power to them. And
pre-soaking the motors in nitrogen.
In dry ice, yeah, they used dry ice. They got them down to minus 80. I mean, nitrogen.
I wasn't expecting to have the right answer.
But you think like it's the record run is like 15 seconds, and in 15 seconds the motor's going from like minus 80 to over 100 degrees.
Wow. Yeah.
So the thermal shock is just bonkers. And
I'm surprised the bell still turns after that temperature change.
I mean,
kudos to RCM Power's engineering.
And RCM Power make a good motor, and they're running it at like twice the rated RPM as well. So like the bearings are getting hot, and it's just everything is again. But we've learned a lot actually, or I've certainly learned a lot about what it takes to make a motor that's capable of doing those kind of speeds. So we now have a new version of the 3220 that's coming. I don't know if we're going to release it for like everyone to buy, because I just don't see the point. But Luke and Mike are going to be using this new version, and they want to try and go. Their next attempt is they want to try and go 624k an hour, which would make their drone the fastest all-electric vehicle of any type ever.
Wow!
So we'll see if that happens. But so that's kind of how I got into the high-speed drone stuff. And then the HS5 was just it's the HS5 is you can build this and it will just work high-speed drone. You don't have to do crazy things with crazy voltages and burn out all your motors and blow up your ESCs. You can just build something that will do 200 miles an hour on 6S if you just use the components in the video, and it will do 200 miles an hour. Or you can run 8S and then it will do more. It will do more. And people have been running it on 8S and getting super, super high speeds. But I mean, that's 200 miles an hour is enough.
Some reading required to go faster.
Some kind of, more
research.
more research and more testing required. Like the 6S version is pretty bulletproof. The 8S version is a bit, you have to make sure you pick the right parts and be careful with it. But people are using it. I mean, the main thing people are using it for is just like chasing fast bikes and cars and stuff. And they don't go 200 typically. It's sort of 150, 160. But the HS5 will keep up with that no problem. So you get some nice footage. I tried to build an HS7, and even my relatively tolerant approach to safety was like, this is
You find yourself walking around with a fire extinguisher all the time. You think this isn't necessarily the right direction.
Well, that was the thing about the HS7 was that it was just big. It weighed like a decent amount, and it was like 220 miles an hour easy. And it was just starting to feel like a bit of a risk. So
I remember, Frank, we had, what was it, a Maguli bird on, and he was making his own custom 14S packs, and he was getting like one run out of these packs. This was on a plane on a wing, and he had a carbon fiber prop, individually like shaped carbon fiber blades that attach to a central hub, and he'd break off prop blades and do 1 or 2 runs on his custom 14S packs before they were just puffed and dead.
My God, yeah.
So
there are people out there who and if you want to do that, I mean, more power to you. I think that's great, but I didn't want to like productionize a 7-inch 200 and what it would have probably been when I finished it and got everything working would have been around 250 miles an hour probably. Would have been kind of the top speed on 8S.
You'd need to sell it with the proviso that people do a course on how to land it safely afterwards, because I'm convinced that most people, when they've got the adrenaline pumping and have done a couple of high-speed passes on these things, they're going to be pretty stuck when they turn around, try and land it, and realize that all they're looking at is the sun, and they can't see any of the horizon even.
Yeah. You do need to practice. I mean, I think it's doable to land it if you've got a spotter who can help you out, or you just put a net up or something so that you just suspend a net so that you can drop it into something soft. But yeah, the HS7 is just another level. So
are there any other FPV trends that you sort of see over the next few years that you're either thinking about or have got in the back of your head?
Yeah, I mean, like trends, FPV trends. I think that certainly for me, I want to try and do a little bit more like tuning guides for not just Betaflight and RG-Pilot. I think that, and it's not a trend, but I think that we need a bit more like educational material out in the hobby for like iNav and like the new Betaflight version. Trends, I mean, I think GPS is just going to become standard on Betaflight drones now with 4.6. So kind of thinking ahead and making sure that all of the prints and stuff for the frames have GPS support, because I think everyone's going to be using that. But yeah, I mean, I don't think we want to go too much further down the kind of route of like maybe remote ID is going to become. It's obviously it's a requirement in the US, isn't it? It's not over here yet. I don't know how many people sort of comply but so that might be a trend. I don't know. What do you guys think? I'm interested to hear.
I think we're going to see something like remote ID increasingly built into the backside of GPSs and being part of like ELRS rather than a standalone unit. Like just wire your GPS to ELRS. ELRS hands the GPS data via MSP over to Betaflight, and you have the receiver and GPS acting as remote ID without needing separate components. I think that's probably going to arrive at some point.
That'd be great if we could do it if your ELRS receiver could just occasionally chirp out whatever's needed for remote ID. That would be perfect, wouldn't it?
It's got Bluetooth already or Wi-Fi or whatever. whatever.
Yeah, it's got Bluetooth, it's got Wi-Fi. I mean, you could even, if you've got like a 2.4 gig antenna on there, you could even just chirp out a packet that your radio just ignores.
Yeah. But I mean, they've got chip antennas. I think chip antennas all that's actually mandated. So yeah.
Yeah. I've never found chip antennas to be particularly good. Do you guys use them?
No, they're not. They're terrible. But why waste your noise, your signal budget on remote ID? I mean, you're optimizing it for control link, not for remote ID.
Yeah.
So.
Yeah, I've tried some of the like ESP ELRS receivers with little chip antennas, and I found that they had a lot of packet loss even at relatively short range.
Yeah.
And then you move over to like the type with a little T, and it's just perfect. Mm-hmm. So I think, I think the chip antennas are kind of cool, but probably only for like tiny whoops and stuff. I think, once you get up to anything reasonable size, you're wanting a little T antenna.
Yeah, for sure.
So remote ID. Any other trends? What do you think?
Well, like you said, I think Betaflight's kind of getting their maturity wise. I think there's going to be more people getting a panic button. So in the middle of maneuvers, if your power loop isn't going where you think it should be, you can just do the kind of freeze. Your quad rights itself and just position holds, so you can take a deep breath and not smash into a wall. I think that's
going to be great. I'm so looking forward to that. That's going to be amazing. Yeah.
Jack seemed to have something on his mind.
Oh, it's all right. We're out of time anyway.
I'd love that. I'd love like if it's all going wrong and you disarm the quad, that it doesn't actually disarm. It just sort of like flips itself around and just like
holds position
until you can collect yourself and then carry on.
Deep breath.
Pause button.
Yeah.
Pause button. That'd be nice. I think that'll be amazing.
No worries.
That should be coming in 4.6, I think.
Yeah, and they're freezing that, so 4.6 should be out by the end of the year, I think.
Oh, fantastic!
There's a freeze message out already, end of August.
Yeah. So I've got my eye on it, because the moment that it starts like coming out into release candidates, I need to start working on my tuning guide series for it. I'm going to do a whole new tuning guide for 4.6, and then also put together a course for people who are doing things a bit more sort of professionally, like for a company.
Oh yeah, the big cine quads, that's going to be so valuable for the kind of like, and now just freeze. Don't disarm that £5,000 lens assembly into the ground. Just freeze it.
Yeah, it's going to be perfect. So I'm looking forward to that. I think it will definitely see Betaflight being used on bigger, more expensive rigs if it's got that kind of functionality, which currently people are using ArduPilot, but ArduPilot doesn't quite fly as good as Betaflight.
If you want to be up close and personal doing chase stuff, you could do a high level pass down a street and program it to do that exact thing several times over with Ardu, couldn't you? But if you want to be tracking sports cars really close and going under bridges and stuff, I'd be slightly skeptical.
Yeah, well, you just won't get. It just will never be quite as sharp and responsive as Betaflight will be, and
it's designed for different things.
Yeah, I mean, and actually, what's really interesting is to see features from one going into the other. I mean, a lot of features from Betaflight, like RPM filtering and bidirectional D-shot and all that support's been added into ArduPilot now.
Yeah.
So I think, and you're starting to see more autonomous features coming into Betaflight.
Yep.
So, I think their feature sets will sort of not converge, but there'll be more overlap between them for sure. So that's probably a trend. Is just these open source projects continuing to borrow from each other, and you're starting to see more and more common features that are appearing in both.
Yeah.
Awesome. Well, I look forward to seeing people tearing around with their Betaflight enabled crop dusting drones.
Nice. Unfortunately, that's all we got time for. Sorry to cut you guys off, but obviously we don't want to upset the editor with our last episode.
Thank you, Mr.
Chris, can you please hang on to make sure all the recordings are uploaded? So please don't go anywhere once we end the show. Massive thank you to all our Patreons. You guys rules. Thank you for helping us carry on. We're not too sure what's happening with the episode next week. Frank's away, and I don't think he's going to return. And Curry has now left, so it'll only be me and Stephen and maybe Carl. So we've got to figure out what we want to do. If we don't appear, then we will definitely be on Patreon for the rest of the month of September to finish ourselves out. But that might be it for LDO until we can figure something out. Thank you, Chris, for being our guest tonight.
You're welcome, guys. I really enjoyed it.
Thank you.
Story.
Yeah.
Thanks.
Yeah, I would love to talk to you more. I'd love to find out your opinion on tricopters and whether you think they'll ever fly good.
Yes.
Yeah. But yep, that's all we got time for. We were joined by a wonderful guest, Chris Foster. Thank you.
Welcome, guys.
The man with the moustache, Stephen.
Cheers. Thanks, everyone.
Andrew / Frank. Good luck in your new endeavors. And please don't die on a Catalina because I will be very upset. My buddy Cole.
See ya.
And I've been Brighton to Fly. You've been listening to Let's Drone Out. Thank you for getting us to 10 years. Good night.
Good night.
Bye.
Bye.
No worries. Unfortunately, it might end.